The word qualitative analysis means that we are checking the quality. We have two types of analysis, basically qualitative and quantitative. Quantitative is what you'll be learning as the last topic of this chapter. The qualitative analysis will give us the information about the various elements which are present in a particular compound. So you have it for organic compounds as well as inorganic compounds. And since we're talking about organic chemistry, we will be learning about organic compounds. So detection of carbon and hydrogen. Carbon and hydrogen are one of the most commonly found elements in organic compounds, and they are detected by heating the compound with copper oxide. So when copper oxide is heated along with the compound, the hydrocarbon, the carbon itself leads to the formation of carbon dioxide. And this carbon dioxide reacts with calcium hydroxide, which is lime water, and it turns lime water milky by the formation of calcium carbonate. The hydrogen, on the other hand, reacts with copper oxide and it leads to the formation of, or rather, it converts hydrogen to water. And this water can be tested with anhydrous copper sulfate, and this will turn so generally the anhydrous copper sulfate is white in color, and when water gets added to it, it changes to blue. So it with the CuSO4 itself is white, whereas CuSO4.5H2O is colored. So this is how we detect the presence of carbon and hydrogen. The detection of other elements. There are various elements which are present in our organic compounds. You have nitrogen, so you have amines which are present. So amines, nitrates, NO2 group added to it, NH2 group can be added to our organic compound, or SO2 can be added, or rather, basically S itself can get added. So there are various compounds like, sorry, elements like nitrogen, sulfur, and halogens like chlorine, bromine, or iodine, which can be present in the organic compound. So they are detected by using the Lassaigne test. So before we perform the Lassaigne test, we will first make something called the sodium fusion extract. So the sodium fusion extract is basically helping us convert the various elements from the covalent compound to an ionic one. So here, in the first case, you will obviously, the organic compound will have carbon and nitrogen. So when the sodium is heated, so basically we heat the sodium and then we will add in the particular compound into it. Okay, and then we heat it a little more, and then basically we dissolve. We generally sodium is supposed to, I mean, sodium when in contact with water will burst. So for safety reasons, it's carefully placed inside a mortar and pestle with water in it, and it's basically mixed into the water. And this in turn leads to the formation of various compounds. And this particular substance in the mortar is called the sodium fusion extract. So if nitrogen is present, it's sodium cyanide, which is formed. In case of sulfur, sodium sulfide, and in case of halogen groups, it's sodium halide. So these in turn will be checked based on various tests. First is the test for nitrogen. So for the sodium fusion extract is first boiled with iron sulfate, iron 2 sulfate, and then it is acidified. So then we'll add concentrated sulfuric acid. And this leads to the formation of a Prussian blue color. And this will show that, you know, the particular compound has nitrogen. So what happens over here is sodium cyanide is reacting with iron 2 sulfate. And this forms this compound called as a hexacyanoiodocyanide 2, basically the oxidation state. You learn about the naming of complexes in the next year. So what happens is on heating, some of the iron 2 will get oxidized to form iron 3. So that's why we're adding the acid. So when the acid is added, the mixture will convert few of the iron 2 to get to the iron 3 state. And this in turn will react with the compound which is formed in the first step. And this leads to the formation of iron 3 hexacyanoidoferrate. Sorry, cyanidoferrate 2 or ferricyanide. And this is the Persian blue color. So first you have sodium cyanide reacting with Fe2 plus. Now, when this leads to the formation of a compound, this complex will react. So then we are adding the acid to it. This makes sure that the few Fe2 plus which has remained unreacted will get converted to Fe3 plus. That in turn will react with the compound which is formed in the first step and lead to the formation of a Persian blue color. Next is the test for sulfur. Sulfur, generally, we are taking the sodium fusion extract again, and we'll be taking acidified. We are going to add acid. Basically, it is acidified with acetic acid. So first step is we are acidifying it, and then we are adding lead acetate to it. And this leads to the formation of a black precipitate that is lead, I mean, lead sulfide. And this indicates that there is sulfur present. There is another method by which we can basically figure out if sulfur is present. We'll be heating the sodium fusion extract with sodium nitroprusside, and this in turn leads to the formation of the violet complex, and that shows that sulfur is present. So if by chance both nitrogen as well as sulfur are present, leads to the formation of a separate compound called thiocyanate. And this thiocyanate gives the blood red color on reaction sodium thiocyanate is formed, and this will give a blood red color on reaction with the Fe3 plus. So this fusion, basically, in this case, you have a blood red color forming on reaction with Fe3 plus. Now, if suppose the sodium fusion extract fusion is carried out with excess of sodium, it leads to the formation of both sodium cyanide, sorry. So if it is done with the excess of sodium, then the thiocyanate which is formed will get decomposed to give sodium cyanide and sodium sulfide. And these will in turn give the usual test. So we learned about when nitrogen is present, we are heating it with Fe2 plus and then acidifying it and then again adding. And basically we observe the Prussian blue. Sulfur also it has its own test, but when both of them are present, leads to the sodium thiocyanide, and this in turn reacts with Fe3 plus to lead to a blood red color. Now, if the sodium fusion, that is the previous step, that is sodium fusion extract is formed with the excess of sodium, it leads to the formation of sodium cyanide as sodium sulfide, and they will give these both tests as usual. So you'll have the sodium cyanide reacting to give Persian blue and sodium sulfide reacting to show a violet color. Next is test for halogens. Test for halogens, one of the easiest ones of the lot. First, we'll be acidifying with nitric acid, and then we'll be treating it with silver nitrate. Now, in case of chlorine, AgCl is formed. In case of bromine, AgBr. In case of iodine, AgI is formed. So AgCl is a white precipitate, and this precipitate is soluble in ammonium hydroxide, NH4OH, whereas a yellowish precipitate, AgBr, which is not that soluble in NH4OH, shows that bromine is present. And in case of iodine, very completely insoluble substance of AgI. In case of bromine, it's sparingly soluble. In case of iodine, it's insoluble in ammonium hydroxide. So AgCl, soluble in ammonium hydroxide. AgBr is sparingly soluble in ammonium hydroxide, and AgBr is yellow. And AgI is completely insoluble in ammonium hydroxide. AgCl is white. AgBr and AgI are yellow in color. So when we suppose, let's assume our compound tested gave a positive result for both nitrogen as well as sulfur. In that case, what we do is we will first heat the sodium fusion extract with nitric acid. This makes sure that the cyanide and the sulfide of sodium will be removed, and this in turn will not interfere with the reaction with the silver. Next is test for phosphorus. That's the last one. So the compound is heated. First of all, the compound in this case is heated with an oxidizing agent like sodium peroxide. And what happens is the phosphorus is going to get oxidized to give rise to phosphate. So the phosphorus is getting oxidized to phosphate. And this is then boiled with nitric acid and is treated with ammonium molybdate. So this is H3PO4. It's boiled with nitric acid, followed by the treatment with ammonium molybdate. This leads to the yellow color or a precipitate that is ammonium phosphomolybdate. And this shows that phosphorus is present. So first step, what we're doing is we're heating it with an oxidizing agent, and this converts the phosphorus present in the compound to a phosphate group. Then what we're doing is we are heating it with, we are acidifying it, followed by, treated with, first you're heating it, boiling it, adding in the acid, so acidifying it, followed by the addition of ammonium molybdate. This leads to the formation of ammonium phosphomolybdate, which is supposed to be yellow in color. And this in turn shows the presence of phosphorus. With that, we're done with qualitative analysis of organic compounds. Generally, when we do the analysis for organic compounds, qualitatively speaking, there are various tests to check for various functional groups as well. So each functional group, like acid, ester, all of them will have their own sets of tests, and that in turn will show that that particular compound has that functional group present in it. So, but then that's not what you're learning now. We just had a basic understanding of presence of various elements like nitrogen, sulfur, halogens, as well as phosphorus, and the presence of carbon and hydrogen, which is the case in all the organic compounds. So with that, we're done with the qualitative analysis. In the next video, we'll be discussing the quantitative analysis.